Hey, welcome back to part 3 of the Spring Data Redis tutorial. In part 2, we got the project off the ground, we got it configured with Spring Data Redis. In this episode, we'll start the test-driven development cycle to flesh out our to-do backend API.
With me, Brian Sambo.
I need the corner.
All right, so now I think we are ready to TDD the heck out of this thing. Okay, so not wanting to make any assumptions, I'm going to briefly explain my definition of test-driven development, or TDD. And it's been around for a long time, and it's signified by that red-green refactor little loop that you see around that TDD on the slide. And what it means is that we start on red with a failing test for our new functionality. And then we write the minimal code to pass a test. That will be the green stage of the cycle. And then we refactor, basically. We clean up and improve without adding any new functionality. If you add new functionality, then you basically, before you do that, you write a new test, and then you actually do the looping part again. I'm a big proponent of TDD. I'm a big proponent of TDD when you know what you're building. Sometimes for exploring or when you have no freaking clue what you're building, the good old main method in console.logs or system.outs seems to still prevail in the industry. As long as you take what you learn and then you codify it into tests. If those tests provide valuable to your application, that's kind of the combination of techniques that I use. All right, so before we get started, one of the things I'm going to do is switch back to our Safari browser and rerun the tests for our application. So we again start with a clean base. So we're going to use a combination of the to-do the to-do backend tests and our own JUnit-based testing, controller-based testing. So let's actually run the to-dos backend tests, and everything's still failing, so we're good. This is one of the few endeavors in life when starting with failure, it's the right thing to do. Okay, so the first feature we're going to tackle, it's going to be how to get the full list of to-dos. And as I mentioned before, we're going to do this in a TDD fashion. All right, so first let's take a look at a test that would actually set the scene for our red stage of the TDD cycle. I'm going to bring up the to-dos API tests. So this is the class that's going to contain all of our controller tests. Notice that it's annotated with the @springboot test annotation. I also have the auto-configure mock MVC. So mock MVC, it's going to be the class that's going to help us send fake HTTP methods to our implementation so we can test them without having to run a full-blown integration test. So notice that I have my mock MVC object, which is also auto-wired. And I have a mock bean, which is my to-do repository. And now the tests in this one, we started with a very basic test that given no to-dos, we get an empty array. So basically just testing the protocol, make sure that we get the right JSON data structure in return. And notice in here that we call the MVC perform. To that, we pass the verb that we want to invoke. That would be get against the /todos URL path. And then we're expecting that the result is going to be an HTTP OK or an HTTP 200. We do that by saying and expect the status to is OK. And also, we're going to expect the content to contain a string representing an empty JSON array. All right, so now let's switch to our terminal and run our Maven tests.
Now, with our first test in place, let's run it and confirm that we're on step 1 of the TDD cycle, aka red. And we are expecting to have 2 tests and 1 failure. One test, it's our actual test that we wrote, and the other is the empty test provided by Spring Initializer. So here on the console, we're going to run nvn test. And as expected, we can see that there are 2 tests run and 1 failure. Now it's time to introduce the controller that is going to power the API. And back on VS Code, let me bring up the initial implementation of the todos controller addressing this first use case. In this todos controller will serve all HTTP verbs for our API. As you can see, we have a class called todos controller. It's annotated with the @rest controller annotation, and we're rooting our API @/todos. We also have injected an instance of todo repository represented by this variable repository and tagged with the AutoWire annotation, so it gets automatically injected. The beauty of IOC. Then we have the method getAll that is going to be serving all todos at the root of our controller. So we're using the get mapping annotation. The get mapping annotation, it's a compose annotation that it's the equivalent to the request mapping annotation with the method specifically set to the get verb. And I prefer this over using request mapping all over the place because it, tells you immediately what's going on in this controller method. Inside of our getAll method, notice that we're returning a list of todos, but the repository findAll method that we're using returns an instance of an iterable. And the reason here is that CRUD repository, it's not a specific repository to a relational system or a SQL database. It's a generic data store. So the assumption of how the data is being served cannot be made, whether it's in one single shot or in a streaming fashion. Therefore, we get an iterable. Since we know we're getting everything in a single shot, in this specific case from Redis, we're going to convert that iterable to a list. And to do that, I'm using the stream support class in converting this split iterator into a stream. And then I'm going to use the collect method with the collectors to list to collect all the elements into a list and return it back to the caller. So now that you have seen the implementation, let's switch back to iTerm, and we're going to run the tests one more time. So let's just up arrow here. I'm going to add a clear in here so we get a clean start. And let's see what we get. Perfect. So now we have reached the green stage of our TDD cycle. We have 2 test runs and no failures. We really only have 1 real test. Remember that the other test is that empty test that we had there before. So before we move on to continuing the TDD cycle, I want to go back to the controller and talk a little bit about the design and architecture of Spring applications. So let me switch back to VS Code. And some of the things that I wanted to bring up, it's that In this specific controller, we have a direct connection between the controller and the repository. And the reason we're doing that is because this is a very simple CRUD application. So we're bringing the controller directly in our only method so far. It's just a pass-through to get data from Redis through the repository. In a more complex application, this pass-through pattern, it's not very common. The logic will be more than just data retrieval and storage logic, and you'll likely have a much heavier business logic tier, and your models will be beefier, and you'll likely need a service layer to handle complex business logic, typically involving more than one business object and likely more than one repository. So in such a case, your repositories will be injected into those service objects. Those service objects will basically be doing the orchestration amongst multiple business objects, multiple models, and the models themselves would have logic specific to that entity, and the services will basically do the business logic of your application, while the repositories will simply do the retrieval, storage, and transformation, serialization of certain parts of the data. Then your controller remains very plain and simple and just controls. It handles HTTP verbs and reroutes to the correct service, potentially marshalling values coming in from the web into some form of Java object that can be used by your services. All right.
Oh, hey, I forgot. One of the things that we want to do too is double check with our to-dos backend JS specs. So let me switch to our browser, and we have the tests in here as they were before, where we basically failed everything. And I'm just simply going to refresh the browser. And as you can see, we are still failing everything. Why is that? Oh, I'll tell you why that is. The problem here is that there is an expectation to be fulfilled in terms of the course headers. And if that is not set up, this complete test suite fails. So we're going to address that in a second. All right, so let's talk about course headers. And course stands for cross-origin resource sharing. So what can I say about course? You need them. They're a pain in the butt to set up in most frameworks. In Spring Boot, it's actually remarkably simple to set them up. Course headers. Cross-origin resource sharing, or course, is an HTTP header-based mechanism that allows a server to indicate any other origins, domain, scheme, or port than its own from which a browser should permit loading of resources. Whoa, that's a mouthful. Who said that? I believe it was Abraham Lincoln. Or maybe I got it from the Mozilla developer page. All jokes aside, anyways, for security reasons, browsers prohibit AJAX calls to resources that are outside of the current origin. So if your local host JS application is trying to hit something over the web, you can really impersonate the collocation of a JS resource in a server-side resource. So I call it the horror movie opposite policy. So the call, it's only good when it's coming from inside the house. So let's switch now to VS Code and see how easy it is to implement course headers in Spring Boot. So on screen, I have the same to-dos controller, and I have added this cross-origin annotation that basically allows me to set up course headers for specific methods in a controller at the controller level. So notice in here that I have the list of methods that I'm allowing course for: post, get, options, delete, and patch. I have a max age of 3 seconds, 3600. I have the allowed headers that I want to basically pass. So the X requested with origin, content type, accept, and accept patch. And I'm allowing all origin. So I'm being very promiscuous here with the origin allotment. Normally you want to basically set that down to a specific domains that you're allowing to interact with your backend, basically. Okay, so now that we have our course headers set up, and hopefully the Spring Boot application that's reloaded automatically, I'm just going to switch now to our Safari-based tests, our JavaScript tests from to-do backend, and just refresh the page. And notice that now we have our top method passing. So the one that says the API route responds to a GET request, that the server is up and accessible, and the course headers are set up. So yay, we are passing one test so far. Good for us. Now let's handle the creation of a to-do. And to do that, we're going to address the post method against the root of our API. So just like we did before, we're going to start with our API test. And let me quickly switch to VS Code, and we can see that I've added a new test in here. Similarly to the test before, I'm using the Lombok builder added to the to-do class to create a new to-do with the title grab your hat. And then I'm going to set the mock expectation for the repository. So when we invoke to-do repository save, passing any to-do class, I will return the to-do created above. Then in the actual test, we're using the MVC mock to perform a post against the /todos root. We're going to set the content type to be application JSON because we're basically sending a JSON payload. And I am sending the payload as a string in here. Notice that being Java, I have to escape the double quotation marks inside of the string. And I'm passing the title grab your hat just as the to-do object that we have for testing. And then I'm going to set the character encoding to UTF-8. And I'm going to expect that the API will return a status of created. And the path of the return is going to be the actual title of the object. As we've done before, as part of our TDD cycle, we're going to switch now to the terminal. And we are going to run our test again. So then our test runs is going to increase by 1. So we will have tests, 4 tests with 3 passing and 1 failure. One of the nice things about TDD is that you catch regressions immediately. And as you are building, being able to switch between looking at your test and looking at your code, it triggers the gears of testing in your brain, and you realize that there's holes in your testing and you keep on adding more tests. Sometimes my test code basically overwhelms the actual application code. And as long as it serves a purpose and it's keeping the quality up of your code, I highly recommend that ratio to be a skew like that. All right, so we can see that we have 4 test runs, 1 failure. So now let's switch to VS Code and take a look at what an implementation for our post would look like. So again, inside of my to-dos controller, I have a new method just aptly named create, which has a @post mapping annotation and a response status of created. So one of the nice things about Spring MVC and Spring Boot, it's that you can, for example, in the case of success, you can add this to the header. So basically, the correct HTTP code, it's added to the response. Our method returns a to-do, and it takes that to-do. And it simply invokes our repository save method. So that's what we were mocking in our test. We were saying when the controller calls the repository save method with any to-do, we're going to return that to-do that we created during the test. All right, so with an implementation in place, we can now switch again to iTerm and once again run the tests. Wonderful. So now we have 4 test runs, no failures. We have achieved success with our post to-dos method. All right, folks. So with that passing test, we have reached the end of the TDD cycle for the implementation of the create a to-do feature. We should also double check with our to-do backend test suite. So let's switch to Safari. And to rerun it, let's just refresh the page. And now you can see that the test, the API responds to a post with the to-do which was posted to it. It's passing. Wonderful. Let's also do some testing on Postman. In the order in which you want to do your manual testing versus your unit testing, it depends on how certain you are of what you're working with. Sometimes I'm testing an API that has a complex payload, and I really need to test it in Postman first, pull the JSON out, do some experimentation, maybe on the command line with that JSON, and then figure out how to craft a test for that specific feature you might be working on. All right, so let's switch to Postman. And as part of the collection of requests that I have in here, there's a create to-do request. So let's open that. You can see that it's a post hitting the /todos URL. And I have, let's see if we have the right headers in here. Yeah, application JSON, perfect. Now let's look at the body. So I have a to-do whose body is just a simple JSON object with a title field and a value of visit Penny Lane. Okay, let's switch to iTerm. And before we run that post, let's go to the Redis CLI monitor. Let me clear that so we can then run the request and see what the output of which commands are being sent to Redis. So let's go back to Postman, and we are going to fire that request. And as you can see, the result that we got back, it's a full to-do object JSON payload. It has its ID, the long, the title that we sent in the post, visit Penny Lane, and the default values for completed, which is false, and order and URL, which are null for now. Now let's switch to the terminal, and we can take a look at what commands Spring Data Redis send against our Redis database. So notice that the first one that it did, it's a S is member. So check for membership in the set of primary keys. So it generated the primary key for our new to-do object, and then it goes and checks first whether the object is in there already. It blindly does a delete of any keys that might be under that primary key. So if there was a hash for an object with that ID, it deletes it, and then it creates one new using the HM set. So it's a hash multiple set, so it sets all the values on that hash. And finally, once it's done doing that, it adds the primary key to the set using the sadd command. Hey, thank you so much for watching. We're almost there. Join me for part 4 of this series when we will finish the test-driven development cycle to flesh out the to-do backend API. And give us a like by smashing that like button. And subscribe for more Redis, Spring, and general Java content.